Okay, so here's from 3.2, Math 9 3.2. So question number 3, those of you that have done that, continue working. If you want to check, I'll do 3A with you. It says write the addition statement that each number line represents. So one of the things that ways that we said to do this, oh, frozen, gotcha. One of the ways that we said that we could do this kind of thing is by starting at a number on a number line and then moving a certain direction to get to your answer. So the addition statement that corresponds to this situation would be 0.8, and it's positive, so you don't have to write a sign there. How do I know it's positive? Because 0.8 and then 1 is to the right of it, and then 2 is to the right of it, so this is in the positive territory. And there's no negatives on these numbers either. Okay? So 0.8, now we have a positive 1.5, so we're adding a positive 1.5. That's what this says. It's positive 1.5, and the arrow goes to the right. And then where this ends up is right here at 2.3. So that's going to be our result. So 0.8 plus a positive 1.5 is 2.3. And that's how you do number 3. Any questions about that? Okay, you guys all got that? Do you have to write the 2 pluses here, the 2 positives? Not necessarily, because it's adding a positive. That's just the same as just 1 plus. So you don't have to. You could write it like that as well. But because we're adding a positive 1.5, that's probably the way most of you did that. All right, I'm going to skip to, I'm going to go to number 4A now. And so write the addition statement that each number line represents. And these are working with fractions. So it's the same idea. You start at the number where the arrow kind of starts at, this arrow bar. So we start at 1/2, and that's a positive 1/2. And we add 5 over 4, a positive 5 over 4, to get to 7 over 4. Okay, so that's the addition statement for number 4. Any questions there? All right, moving on. Determine each sum for number 5. So 3 plus 2, you can determine each sum however you wish. It doesn't say you have to use a number line or whatever. So this one's pretty easy. 3 plus 2 is 5. We know that. Now, why would we start here? Maybe because this helps us to understand how to add some decimals too. Notice that in the second part, I have a 3 as a whole number and a 2 as a whole number. So that looks like it's going to get us to 5, at least 5, right? And then 0.8 plus 0.4, 0.8 plus 0.4 is 1.2. So I have 5 plus 1.2 is 6.2. That's one way of doing it. That's a way you could kind of work through this in your head. You have 3 holes and 2 holes. That's going to give us at least 5. Then 0.8 and 0.4 is another 1.2. So 5 plus 1.2. The other way you could do it is you could turn each of these into, 38 plus 24, right? You could move the decimal over 1 for each. 38 and 24, that might be easier for you to do in your head. Could you just do this on your calculator? You could. I don't really want you to. I want you to try and work through this mentally. But 38 and 24, that's going to give us what? 50, 62, and then you have to move that decimal place back 1, so 6.2. Okay, so you should have some skills. Either use the number line, use mental math, whatever, to determine these sums for number 5. All right, number 6. Number 6 and number 8 are very similar. Number 6, let's read this carefully. Which of the following expressions have the same sum as this right here? Now you could just find the sum of this and then find the sum of all these, but that's the long way. Okay, that's the long way. What we're hoping, what the textbook question is hoping that you will do is recognize that we have 2 negative numbers that are being added, and when you add things, the order doesn't matter at all. Okay? So if I see negative 2.3 plus negative 1.9, I know that that's the same as negative 1.9 plus negative 2.3. So do I have that somewhere? Yeah, I do right here. Okay, so they just switched the terms around It doesn't matter what order they're in when you're just adding them. So they just switch them around there. Now let's check the other ones though. These are both positive. That's not the same, so it's not that one. One's negative and one's positive. Nope, they're both negative, so this is not right. And then let's see, negative 2.3 plus negative 1.9. Oh, there's brackets around the negative 2.3. Does that change things? No, it doesn't. So guess what? Looks like this one. I think this one should be the exact same as well. Now it says use the number line to explain how you know. So this one does say use the number line. So let's see. If I have a negative 2.3 right here, that's where I start, and I add a negative 1.9, then I'm going in this direction. Okay, and let's see, what does that give us? That gives us negative 4.2, I guess. So finding the answer here using the number line might be helpful. But how does that help us here? Well, negative 1.9, if I start at negative 1.9, that's going to be right about here. And if I add a negative 2.3, that's going to get me to the same spot. And then, of course, a negative 2.3 and a negative 1.9 in brackets, doesn't matter. So all these get you to the same answer on the number line. Any questions about 6? Because 8 is just the same, it's just using fractions. So again, I have a negative 3/4 and a positive 7/8 that I'm adding. So I look around and I see, oh, here's a negative 3/4 and a positive 7/8. That looks great. Any other ones that are the same? This negative here is on the 7/8, and this is on the 3/4. So does that work? Is that the same? We better check this out. So if we use a number line, let's see, we have, here's 0, here's negative 3/4, and plus 7/8. So that's going to be like, this is 6 over 8. That's what 3/4 actually is. So that's going to be negative 1/8, looks like as an answer. No, sorry, positive 1/8. Okay, so if I go negative 7/8, that's over here a little bit further, and I add 3/4, so that the 3/4 is going to be this size right here. So if I add that, I'm not going to get to the same number, am I? So that one doesn't work. Doesn't work. The number line might not be your best way to do that, but if you can kind of visualize this in the number line, it might help you down the road, okay? Anybody have any questions about 7 or 8? Or maybe that was 6 and 8?
Have to draw a number line for every question?
Well, where it says use a number line to show how you know, then yes. Yes. But listen, for this 8, you don't have to draw a number line for A, B, C, and D. You just kind of have to draw a number line and then just kind of work it out. So you can use the same number line. You can use the same number line. Negative 3/4, right? And negative 7/8 takes you way back here. You know the answer is right here. So it's just asking you to kind of show a number line and then just kind of visually work out these solutions to see which gets to the same one. So yeah, try and stretch yourself here and use a number line even though that might not be your first choice. Okay, so if we take a look at 11I, what I would do is probably turn this into improper fractions. So again, just leave the negative out front of the improper fraction and kind of like ignore it when you do this part. 4 times 3 is 12 plus 1 is 13. So 13 over 4. This one is going to be plus minus what? 6 times 2 is 12 plus 1 is 13 over 6. All right. So if you're adding or subtracting rationals, probably a good idea to get a common denominator. So that would be the easiest thing to do here. We have to find an exact number. So a common denominator. You could go to 12 here, or you could multiply 6 times 4 and go to 24. Doesn't really matter. So you could have a common denominator of 12 because 4 times 3 is 12 and 6 times 2 is 12. So that would be the lowest common denominator. Or you could go with 6 times 4 and go to 24. but you're just dealing with bigger numbers there. So I'll do the 12 one. So 4 times 3, and then 13 times 3. That gives us negative 39. 13 times 3 is 39 over 12. And then this one is times 2. Oh, wow. Times 2. That's nice. So that's going to be negative 26 over 12. So now we have the common denominator. Just simply combine the top numbers. So negative 39 plus a negative 26 is like negative 39 minus 26. Or you can add these numbers and make the answer negative. So 39 is pretty close to 40. This is how I kind of work this through in my head. So 40 and 26 is 66, so I got to subtract 1, so it's 65. So negative 65 over 12. And can I simplify that? Is there anything that we can divide 12 and 65 by, like 3, 4, or 6? If not, then that's your simplified answer. So I'll just talk about 12 here. Somebody asked about 12 earlier. What can you say about the sign of the sum of two rational numbers in each case? So what this is saying is that what sign will the sum be? That's the sum is the result when you add, right? So the two rational numbers in each case include an example and explain your reasoning. So both rational numbers are positive. So when you add two positive numbers, the result, is it positive or negative?
Positive.
Yeah, it's always positive. So you would say always positive for A, and then just give two examples. 5 plus 1 is 6. Positive 5 plus positive 1 is positive 6. B, both rational numbers are negative. So we talked about that too, right? If you have a negative number and then you add another negative number, the answer is always negative when you add. Yeah, when you multiply, yeah, it's always positive, but when you add, it's always negative. And then if one rational number is positive and one rational number is negative, that's the tricky case, right? So sometimes it's positive and sometimes it's negative. Do you know why? It depends on which one is larger, exactly. So it'll be positive if the positive number is larger. The answer will be negative if the negative number is larger. So when you say a larger negative, it's like negative 100 is a larger negative than negative 2. So if the actual value of the number itself on the for the negative term is larger than the one for the positive, then the answer is going to be negative and so on. So you just have to explain that for number 12. So in number 15, on Tuesday, December 23rd, the lowest temperature in Winnipeg was negative 13.4 degrees Celsius. By noon the next day, the temperature had increased by 5.7 degrees. What was the temperature at noon? So we have, for A, we have negative 13.4, and that went up by 5.7. Okay? So this is the addition statement that we're looking for. So 13, that's on the negative side, right? So here's negative 13.4. Here's negative 13. And we're going to go up 5, so we have to kind of like take away 5 from 13 because we're going closer to 0. So that's going to be 8. So negative 13 plus 5 is negative 8. I have 0.4 over here, and then I have 0.7 that I'm adding, so that's 0.4 and 0.7. So here's 0.4 to get to 13, and then when I get to negative 8, again, you can do this on your calculator as well, which we will in a second. We have another 0.3 to go. So if you draw your number line, if you have graph paper, good idea to draw your number line maybe with the squares, and you could actually count by 0.1 or 0.4 or whatever. You can actually do that. So what do we got here? Negative 13 plus 5 is negative 8, and we got to go negative 7.7. looks like. Let's check with our calculator, see if that's true. So negative 13.4 plus 5.7, negative 7.7. So negative 7.7 degrees Celsius would be your answer for A. And just make sure you have this addition statement to accompany that, okay? On Wednesday, December 24th, the lowest temperature was 3.7. Oh, it was 3.7 degrees Celsius less than the lowest temperature the previous day. Okay. So it's this temperature minus 3.7. What was the lowest temperature on Wednesday? So it looks like we got to go negative 13.4. That's the lowest temperature on the 23rd. And we got to subtract 3.7 from that. So negative 13 minus 3 is negative 16. 0.4 and 0.7 would be 1.1. So negative 17.1. Check that on your calculator. 13, whoops. Negative 13.4 minus 3.7. Yeah, negative 17.1 degrees Celsius for B. Then sketch the thermometer to show these changes in temperature. Okay, so a thermometer it's up and down, right? So here we go. Let's try and make a thermometer here. So where did we start? Negative 13.4. And then we went up 5.7. And we got to negative 7.7. Then we went down from 13.4. We went down 3.7. And here is negative 17.1. So those are the temperatures that we were talking about. Okay. So that's how you do 15. And I'll let you work on 20. I guess the last one in your assignment there. Let you work on 20 on your own. Any questions? Well, in the last few minutes here, keep working until the bell. There's some of your questions from your assignment today.